Section 9.2, Part 3, Confidence Intervals for a Population Mean. Lesson Objective: Construct a confidence interval for a population mean. Lesson Objective: If you recall, a confidence interval for a unknown parameter consists of an interval of numbers. The level of confidence represents the expected proportion or percentage of intervals that will contain the parameter if a large number of different samples is obtained. The level of confidence is denoted by 1 minus alpha times 100%. In this class, 90%, 95%, and 99%. So this is the formula for the confidence interval for the unknown population mean. If you recall, this is our t statistic that comes from table 6. This is our point estimate for a population mean mu, x bar. This is the sample standard deviation, and then this is the square root of n. N is our sample size. Note, the interval is exact when the population is normally distributed. It is approximately correct for non-normal populations provided that n is large enough and our rule of thumb is 30 or more. Let's look at a visual. So if we have a confidence interval 12 plus or minus 2, our point estimate is 12, our margin of error is 2. So if we think of this on a number line, point estimate 12 is here, and then if we subtract our margin of error, we get 10. And if we add the margin of error, we get 14. So this corresponds to a confidence interval of 10 to 14. Notice the point estimate is always in the middle of the confidence interval. So how do we compute the margin of error? If we look back at our Facebook example from the previous video, we have 40 users of Facebook, and we want to construct the margin of error using this example. So we're going to use the social networking website data and a 95% confidence level to find the margin of error for the mean number of friends for all users of Facebook. We're going to round to 1 decimal place. So if you recall, this is the formula for our margin of error. We have our t-value, sometimes it's called the critical t-value, times our standard error. So since we're doing a 95%, alpha is 5%, 0.05. Therefore alpha divided by 2 is 0.025. And if we use this value for the column, and our degrees of freedom is n minus 1, which tells us our row is 39, we get a t-value of 2.023. S can be computed using the raw data. We can put that in Minitab or StatCrunch or use the graphing calculator. So S, the sample standard deviation, is 52.63 rounded to 2 decimal places, and our sample size is 40. So we have all the values needed to compute the margin of error. So all we do is substitute them in. Our t alpha over 2 is here. This is our standard error, and if we multiply these two values, we get E is approximately equal to 16.8. So the margin of error is about 16.8 friends. Now if we want to construct a 95% confidence interval for the mean number of friends of all users of Facebook, we're going to use our point estimate and what we just computed, our margin of error. So our point estimate was 130.8 friends, and our margin of error was 16.8. So the left endpoint, or the lower limit, would be our point estimate minus the margin of error, which gives us 114.0. And the right hand endpoint, or the upper limit, is our point estimate plus the margin of error, which we get 147.6. So these two together make our confidence interval. So we are 95% confident that mu is in between these two values. Now if you recall from 9.1, this is one way we can express a confidence interval. We can also express it this way, and we can express it as point estimate plus or minus margin of error. If we think about this visually, on a number line, our point estimate is in the middle, and this is our lower limit, this is our upper limit. So we believe the true population mean is somewhere between these two numbers with 95% confidence. Let's do another example. If you recall the text message example, we have 500 college students aged 18 to 24 that produced a sample mean of 729 text messages per month. If the sample standard deviation is 150 text messages, construct a 95% confidence interval for the population mean text messages per month for a typical college student. Round to the nearest hundredth, 2 decimal places. So let's compute our margin of error. If we're doing a 90%, that means alpha is 10%, 0.10. Alpha divided by 2 is 0.05. So this is going to be our column in table 6. This is going to be a row, n minus 1. 500 minus 1 is 499. So this tells us what row, and this produces a t-value alpha divided by 2 of 1.646. So you can check this using table 6. S was given in the problem as 150 and n is 500. Substituting these values in the formula, we see that our margin of error is 11.04. So the margin of error is about 11.04 texts. So if we construct the confidence interval for the mean number of texts of all college students, we use our point estimate, x bar, 729, and our margin of error, which is 11.04. So the lower limit becomes 717.96, and the upper limit becomes 740.04. So our confidence interval is 717.96 to 740.40. Our last example, a student body at many community colleges is considered a commuter population. The Student Activities Office at a certain college wishes to obtain an answer to the question, how far one way does the average community college student commute to college each day? A random sample of 300 college students from this college was identified, and the one-way distance each commuted was obtained. The resulting mean was 15.22 miles, and the standard deviation was 5.95 miles. Estimate the mean one-way distance using a 95% confidence interval using the sample data. So x bar given in the problem was 15.22 and S was 5.95. Alpha is 0.05 because we're using a 95% confidence level. N is 300, therefore our degrees of freedom is 299. So our T alpha divided by 2 is 1.984. And again, this is coming from table 6. Our lower bound is our point estimate minus our margin of error, which is 14.53. And our upper bound is the point estimate plus our margin of error, which is 15.90. So the 95% confidence interval for the mean distance is 14.53 to 15.90. Thanks for watching.